everyone, welcome to the next video in this unit. We're going to be talking a little bit more about the definite integral. Here are the objectives, and we're going to work some examples. So what is a definite integral? Well, so far we've been talking about the indefinite integral, and that's talking about just the area under a curve, but it's not over a specific distance, it's just under the curve. But a definite integral means finding the area under the curve from one value to another, from A to B of this, and it's always from the bottom to the top. So here's an example of what we're talking about. We want to find the definite integral from 1 to 2 of 2x dx. And so here's how you write it, from 1 to 2. And so when you graph 2x, remember it's just a line, we're trying to see what is the area in region A that is set up between 1 and 2. And you'll recognize this is a set shape. This is a trapezoidal shape. This is the height, base 1, base 2, right? So the indefinite integral would say find the area under that curve from 2x dx, right? So it's not a specific integral, and so your answer once you integrate it would be x squared plus c. All right, so if we evaluate this at x equals 1, right, we substitute a 1 in here for this x squared plus c, then we would have 1 plus c. And then if we put the 2 in here, 2 squared is 4 plus c, right? And we subtract these two values. So we take 2 squared plus c minus 1 squared plus c, and then distribute the negative and everything. We see here that we have 4 minus 1 plus, and then the c's, c minus c, the c's go away, so the constant value becomes non-existent, and therefore we don't need to worry about it. That's why the c goes away in a definite integral. And then the value of that is 3. And so what you have found is that the area of this trapezoid underneath the line is 3. Now, if we look at it, evaluate it this way, we say you find the integral, right? So they didn't write all this here. I probably would have, if I had had the, if I had done the integration, I would have done x squared from 1 to 2, right? And then that would have gotten me 2 squared minus 1 squared equals 3. And then here, this shows geometrically, this bottom part down here shows geometrically what's happening. You're finding the actual area under that function. Okay. Okay, so this next one says find the definite integral from 0.5 to 1 of cosine x dx. All right? And so you can see here that it looks a little bit like a trapezoid, but it has that curve. So we can't find it geometrically, so we're going to use calculus. So I'm going to take the integral of cosine x dx, which is sine x, right? I want the definite integral, so I'm going to go from 0.5 to 1. We evaluate this by saying the sine of 1 minus the sine of 0.5. Now remember, these are angles in radians. So you're going to need a calculator that is set to radians. So as I reach for my calculator, and I make sure it's in radians, and then I put in the sine of 1, close the parentheses, minus the sine of 0.5, and hit enter, I end up with 0.36205. And that is the area under that curve from 0.5 to 1. So in this example, we want to find the definite integral from 0 to 1 of sine x dx. You can see the picture there, right? We're looking for an area. The area will be above the x-axis, so the area will be positive. Okay, so I'm going to take the integration. I'm going to integrate sine x to negative cosine x from 0 to 1. And when I write this out, I have negative cosine of 1. Now remember that these are angles in radians, because sometimes people think that they are values instead of angles. And then minus, and then I'm going to put that in parentheses, negative cosine of 0. Now, this part is really important because you are subtracting something that is negative, so you end up with positive. So when I do this, negative cosine of 1 plus cosine of 0, I get 0.4597. And notice that that is positive, and this was also the area underneath the curve of sine x from 0 to 1. Now, the definite integral from 1 to 3, notice that parts of the area under the curve are above the x-axis and some are below. So the area that is above is going to be positive. The area below will be a negative area. And once again, we're still talking about direction. One of the ideas behind integration is if, for instance, you were in particle motion, right? And if a particle moved to the right, that would be a positive sum. But then if it was moving back to the left, that would be a negative sum. And so we don't have the parametric mode on, just the regular function. We're seeing that it moves right, then left. Okay, so this will be really important then to note that the area is not really negative area. It's still talking about a direction. So anyway, let's work this problem. So we have from 1 to 3 of cosine x dx is going to be sine x from 1 to 3. So I have the sine of 3 minus the sine of 1. And then when I do that, I'm going to get negative, because notice that the negative area is bigger than the positive area, so I'm going to end up with a negative area. Okay, so the definite integral will work out the net area. Okay? Okay, one more. What is the value of the definite integral? All right, so we have from negative 2 to 3 of 3x squared dx. So I want to integrate. So I have 3x to the third over 3, which is the same thing as x to the third. And I want that from negative 2 to 3. So that's going to be 3 to the third minus negative 2 to the third. So this is 27. And then this will be minus a negative 8. So that's plus, and so that will be 35. Okay, so obviously we have found that between there's part of it that's below and part that's above, and this is going to be the net area under the curve. So we're going to do a lot more of these in class and do some practicing, so I will see you then.